Welcome to the MENARA tool. MENARA is a web-based policy support system for understanding strength, weakness, opportunity and threat that scales from pixel through to regional, national and indeed global. It does this SWOT analysis considering factors such as environment, water, energy, food, economy and population. It's really a horizon scanning tool that is designed to identify material threats, opportunities and potential choke points that may precipitate conflict. And it's designed to help think through locally appropriate policy responses to strength, weakness, opportunity and threat. A MENARA is a lighthouse in Arabic, and this tool is really aimed at shedding light on turbulent waters. It was developed as part of a European Commission Horizon 2020 project of the same name. To get to MENARA, you go to the policy support website, www.policysupport.org. If you don't have a free account for other tools such as Waterworld and Costing Nature, then you can simply create one at this link. And to access the policy support system, you simply click the Access PSS Here link. This will open a window looking like this, in which you will then need to type in your username and your password that you set up when you created an account. You would then log in, and you'll see a map focused on the Middle East and North Africa, and you can run MENARA either for these blue tiles, we call them, at 1 kilometer spatial resolution, so they are more or less large enough for national scale type analyses, or you can zoom in and run with 1 hectare resolution land cover, terrain and land use data for areas of this size, which is around 1 degree of latitude and longitude, or 100 kilometers on each axis. They are therefore for local scale analyses. However, most people, I think, would want to run this tool for one of the list of countries or major basins that they may be interested in. To do so, you simply open up the drop-down list and you type in the first couple of letters of your country. So I've typed in TU for Turkey, but of course we first get through the list of basins, so if we type TU again, we'll get to the countries beginning with TU and we can choose Turkey. We then need to give this a name indicating in our own records what the analysis was for. So I'm going to call this test for Turkey, and then we can click define area. What we see then is that our current run, as indicated here, now has our name that we set up, and we have some details here of the situation for that run. We also zoom into the area in which we have generated that analysis. We then have a series of other steps. That was step 1. Step 2 is the prepare data step. This gets together all of the data behind MENARA in the so-called SimTerra database, which also underpins Waterworld and Costing Nature tools. After that, we run an analysis using step 3, start simulation, and then finally we would go to step 5, results maps. And this provides us with a baseline analysis of strengths, weaknesses, opportunities and threats throughout the whole of Turkey at 1 kilometer resolution, focused on data largely from 2010, but also looking into the future in terms of climate change, population projections and so on, as we'll see. So I'm going to click the prepare data step, You'll see that there's lots of extra detail here, which are really for more specialist use. So the simple scientist version that we're using here hides that, but we simply need to copy data to our workspace. This will take a few minutes. This process gathers more than 100 data sets, 164 as you see here, from the SimTerra database, and prepares them and copies them over, checks for inconsistencies between them, and fixes those, and then will provide us with a long list of the input data so that we're ready to do an analysis. So I'm just going to pause whilst we wait for this to happen. Okay, so a couple of minutes have gone by now and the data has prepared, and we see here show workspace data with a small plus next to it. That plus is used to hide detail in the interface. We can click that plus and we will see all the data sets that are used in this analysis. Those that we have produced or we have a license to redistribute as geographical information systems data are downloadable. The other ones you have to go direct to the original data provider, because we don't have a license to redistribute them online. But as you can see, for many of them you can visualize the inputs using this green icon here, and that can give you an idea of what's going into the model. So let's just have a quick look at one of these variables, maybe the cover of tree covered ground. This is tree cover in Turkey. We click the green icon, and in doing so we are shown a map but also the citation for the original data, and this map goes from blue through green to red with increasing percentage cover of trees in these pixels. We can look at the map in other ways, for example as a histogram with cover of tree covered ground along the x-axis here, and the frequency or number of square kilometers under each cover. And you see much of Turkey is low tree cover, but a few areas are forested, relatively high tree cover. We can also look at this in a Google map or in Google Earth, as you can see here, and we can zoom in and get a feel for where the tree cover is. We can change the transparency or indeed switch the overlay off so that we can see the imagery underneath and therefore confirm what we're observing in the data. We can also query the values of individual points either by typing in place names here and then clicking query. For example, we could type in Istanbul, where we don't expect to see a great deal of tree cover. Then we'll be zoomed in on Istanbul, query, and we see that there's no data there because we're just outside the tree cover map, very close to the coast. That's what nan means, not a number. We can also query anywhere else just by moving the map so that the crosshair of course always remains in the middle, and we click query. 56% tree cover in that particular pixel. So we'll close that and go back here, and we can also view this in other ways, not just by pixel but in a variety of other ways. So if we wanted to look at the tree cover by region, we can type in region, REG. That will take us to regional administrative boundaries, and we will then see a new map in which the tree cover is averaged per region, and so you can see high tree cover regions in the north here, low tree cover regions in the center. And again we can look at this in a Google map or Google Earth and check or query the values. And we can do that, of course, for some of the input maps where we are able to redistribute them in terms of a visualization, and we can do it, of course, for all of the output maps. So the next step is then step 3 to run an analysis. So we click Start Simulation and then simply click the Start button here. Again, this will take a few minutes, so I'll pause the video briefly whilst the model runs. And as you can see, it starts going through the analysis, building up the different methods, starting off with preparing the data and then moving forward into the different types of analyses. You see we're calculating downstream sums here, and in a few minutes the model will have completed. If you're running this for the first time in an area, it may take a little bit longer because some calculations only need to be done once and then they're stored, and so if no one else has run that particular area, then you'll be doing that. So you see the analysis has completed now, but before we have a look at some of the outputs, I'll just say a little bit more about the analysis that's just occurred. We map strengths, weaknesses, opportunities and threats. These are all material factors. Some of these factors are both, for example, strengths and weaknesses. Some may be threats and opportunities, but there are around 8 of each category. So under strengths, for example, we have the strength of infrastructure, the presence of mine, oil wells, pipelines, roads, dams, urban areas. These are all considered infrastructural strength. Accessibility, being within 3 hours of a market, is considered to be a strength. Per capita agricultural productivity, volume of water supply per capita, the potential for nature-based tourism, the quality of water supply, and GDP are 7 strengths that we're mapping, and these are all mapped globally, largely on the basis of detailed remote sensing database and analyses through simple models. Weaknesses include number of poor people, proportion of available water that's polluted, water supply per capita, that is the scarcity of supply, rather than the volume of supply, which was of course a strength. Agricultural productivity per capita, again scarcity of productivity. Remoteness is considered a weakness. If travel time to population centres is very high, that's considered a weakness. So is rainfall seasonality in agricultural areas or resource providing areas that also include the watersheds of dams. Pressure on natural capital, from, for example, population pressure, fire frequency, grazing intensity, agricultural intensity, dam density and human infrastructure. And risk of natural hazards. These are all weaknesses that are mapped. Future opportunities include natural resources, the presence of natural resources, coal, mining, surface water, coasts and tree cover are all considered resources. Surface water because of fisheries and water itself, coasts because of, again, access to fisheries, tree cover of course for timber, and then coal and mining for minerals and fuel, energy. Agricultural potential is also an opportunity, so we look at suitability for croplands and pasture as a measure of future agricultural potential. The absence of threat to natural capital, the inverse of the previous category, is considered an opportunity. Where climate change brings more rainfall, that's considered an opportunity, and so we have IPCC climate scenarios in here. Population density growth is considered both an opportunity and a threat. Solar power potential, wind power potential and hydropower potential, all of which are modeled spatially, are considered opportunities. And then finally, the threats that we're dealing with include population density, the growth in population density, which is both an opportunity and a threat, where climate change will bring less rainfall, then this is considered a threat. Remoteness from towns is also a threat, because those very remote areas have governance challenges, and threat to natural capital, of course, is considered a wider threat. So these threats include planned roads, accessibility, distance from deforestation or proximity to it, change in GDP, population change, temperature change, precipitation change, the intensity of nighttime lights, and the presence of natural resources. All are a threat to natural capital. Natural resources there being mining, oil and gas, for example. And then finally, two final threats are the potential for soil degradation and the proximity to national borders, which are considered a threat in terms of both migration, refugees, and international conflict. So those are the kinds of calculations that are done here. So if we now have a look at step 5, results maps, to get an idea of what we see, we have a whole series of indices that start at the bottom with the simplest and then grade upwards to the more sophisticated. And so of course the first map that we have here is a map of the greatest renewable energy potential. So this takes the outputs of the solar energy, wind energy, and hydropower energy maps, and classifies in each pixel for Turkey which is the dominant or the maximum potential of those three, so that we can see throughout much of this particular country, solar energy is the greatest potential, but really only in a band around urban areas. Of course, within urban areas, land prices are too high. Far away from urban areas, the grid infrastructure isn't there. So most of the area of the country is, of course, has no greatest renewable energy potential, because there is no renewable energy potential, largely because there just isn't the infrastructure there at the moment. But elsewhere there are a few isolated areas where we have wind potential. You can see these in brown here, and if we zoom in much closer, we can see where rivers are providing hydropower potential if run-of-river or reservoir dams were put in. So we can see here that this is one of our variables, and it's mapped for any country that you look at. Again, we could view that by region. Again, so regional administrative boundaries. This time, of course, we won't average this, but we will instead look at the majority in each administrative region, and for most of the regions you see the majority is indeed no potential. Right? The majority of land has no potential, but we have a few regions here where the majority of land has either solar or wind potential, and these should be considered to be important regions. Okay, so we'll then look upwards. We're going to skip over a few of these. We can see that we have a series of variables based on the least strength, weakness, opportunity, and threat in each pixel, and a series based on the greatest strength, weakness, opportunity, and threat. We then have the strength, weakness, opportunity, and threat indices themselves, and then the overall prognosis variables. So let's have a look at the strength index first. So this is the strength in each pixel according to, as you see, infrastructure, per capita agricultural productivity, and all the other things that I mentioned. All the images go from blue is low to red is high, and are normalized between 0 and 1. And of course what we can see is that we have quite a lot of areas where strength is low. These are away from infrastructure and are not accessible. We have a few areas where strength is very high, where all these variables combine to produce great strength. Now if we want to know exactly why that is, that's easy. We just move the map so that our cursor is over an area of interest, such as here you see we're just looking around Ankara, and we click inputs here. That gives us a blue icon which we click, and then we have a list of the inputs to that variable and their values, and we can see the overall strength in this pixel comes largely from strength in GDP and in infrastructure, whereas there is in fact of course weakness in all of the other variables. But nevertheless, because of the very large strength in these variables, there is significant strength overall. It's one of the stronger pixels or stronger areas in the country. If we pick an area with low strength and click inputs again, let's have a look at that. Show, and we see this is weak or low strength because of the absence of strength in all of these variables, perhaps except agricultural productivity. This is clearly a piece of agricultural land with some strength, but not a great deal. So that's the strength metric. Weakness is here. Again, 0 to 1, blue to red. We can see the areas where the different variables combine to produce weakness. So let's have a look down here, for example, inputs. And here you see weakness is made of this whole set of variables, and this part of the country is weak because it has high seasonality. The developed areas, the human used areas, are relatively remote. There is significant water scarcity and production scarcity in agriculture. There's quite a bit of pollution, and we have quite some pressure on the environment. Whereas if we visit an area where weakness is lower, then we can get an idea why that is. So let's have a look over here. Inputs, much less weak, 0.29. We have some weakness in terms of seasonality and per capita vegetation or agricultural production scarcity, as well as human pressure on the environment, but the other metrics do not show weakness. And again, of course, we could look at this by region or by sub-basin or other units, and see the broad pattern of weak versus strong regions. We see a cluster of weakness in the east here. So strength, weakness. Now opportunity. Opportunity, as you see, from natural resources, agricultural potential, climate change leading to more rainfall, population growth, solar power potential, wind power potential, and hydropower potential. So opportunity is, as you see, variously distributed. We have particular opportunity on the east, on the west, I'm sorry. You can see the patterns associated with some of the mineral resource concessions. You can see patterns associated with solar power potential and wind power, and so on. We have a look why we have such high opportunity apparently over in the east here. Query the inputs, and The overall value of opportunity here is very high. It's the highest combination of opportunity, and it's made up of significant opportunity in agricultural suitability, lack of threat to natural power capital, solar power potential, as well as wind power potential. So that's opportunity, and then finally, of course, we have threat. This is the map of threat. You can see that we have particular clusters of threat in the north, and a lack of threat generally in the center. If we work out again why these areas are considered threatened, we have some significant change in population density over the last few years. We have potential for land degradation. We have threat to natural capital, and we have quite some remoteness there, and we have proximity to land borders. These combine to create significant threat in that region. And then we see the same down here, possibly for different reasons. Low population density, but quite some growth, degradation potential, significant threat, not so remote, but climate change leads to a decrease in rainfall in this area, and we are proximate to a land border. So strength, weakness, opportunity and threat are mapped therefore at the pixel level, as you see. We can of course for each pixel put those together to look at what we call the future prognosis index. This is essentially the strength plus the opportunity minus the weakness plus the threat, and then normalized. So if this value is high, then we expect a positive future on the basis of material factors and constraints. If this value is low, then in human terms we see challenges in the future. And so again we can check an area that's low and work out why. So just looking at this area underneath the cursor here, the overall value is very low because this is an area that has a significant threat level, but it also has very low opportunity. It happens to have quite low weakness, but it has very low strength as well, and that's why this is overall looking at a relatively poor material prognosis. If we try another area that has a much higher prognosis index, we can see it's an area of strength, relatively low weakness, very high opportunity, and again low threat across all of those factors. So you can begin to see perhaps how we with these data sets can begin to understand how multivariate analyses in a whole range of different areas of environment, population, urbanization, agriculture, resources, energy and so on can help us to understand overall the stresses, choke points and material futures. Of course, the way that these material factors play out on the ground is affected also by other things, in particular by politics, by democracy or lack thereof, by ideology and other so-called ideational factors. They are not the focus of this system. We're focusing on material factors that can be mapped, but of course understanding these material stresses can help you understand and work with some of the ideational factors too. So that's the future prognosis index. We can then look at perhaps the most and least significant attributes in each pixel. So if we look at the most significant attributes, what we're looking at here is whether an area is characterized by the highest strength, or is weakness higher, or is opportunity higher, or is threat higher. And so this map shows us in red areas where strength is highest, in brown areas where weakness is highest, in grey areas where opportunity is highest, and in this dark, almost black colour, areas where threat is highest. And so we can begin to see the key attributes of different areas when we put all of these variables together. So that's the most significant attribute. Of course, each pixel also has a least significant attribute, that attribute with the lowest value, and since everything is normalized, these values can easily be compared, and so you see that for most of our rural areas, strength is the lowest, and then we have other areas where threat is the lowest, particularly in the center of the country here. We have other areas where opportunity is pretty low, and other areas, although not so many, where weakness is the lowest variable. So that's the least significant attribute. We can then, of course, go back to our different indices: strength, weakness, opportunity, and threat, rather than the overall prognosis, and we can look at which of those attributes is greatest or indeed least. Let's just focus on the greatest ones. The greatest strength in each pixel we see here. These are the list of variables that contribute to strength, and what we see is that we have quite a complex distribution of some areas where accessibility is the greatest strength, others where it's GDP, others where it's per capita water availability, others where it's nature-based tourism, and so on. And of course, again, we can pick any pixel, look at the inputs, and see how that is made. So that's greatest strength. Greatest weakness we have here, and again quite a complex distribution, with some areas weak because of seasonality, that being the greatest weakness, other areas because of per capita water scarcity, other areas because of risk of natural hazard, and so on. And quite a detailed textured map, of course, because of the huge variation that we have in the 100 and more maps that are going into this analysis. So that's weakness, the greatest opportunity, so here again we have a much simpler view where over much of the land the greatest opportunity is, as it says, number 3, natural capital security. This means that there is little threat to natural capital, so there is opportunity in that natural capital, for example, providing and continuing to provide ecosystem services. So that's the greatest plus for the future. In other areas, of course, we have population growth as an opportunity. Around that, we may have other factors such as this one here, agricultural potential on the outskirts of urban areas, but also in some cases solar power potential, and so on. So we can see how that works out spatially. Greatest opportunity, and now the greatest threat. So you see the map of greatest threats here indicates again a complex pattern with governance challenges in some of the more remote areas, threat to natural capital in some of the more populated and developing areas, climate change bringing less rainfall in other spaces, and population growth, border proximity, and others. So again, this helps us to explain particular combinations of factors leading to strength, weakness, opportunity and threat in particular areas. And of course we can then look to what extent they coincide with conflict or other challenges that are occurring within those regions. And of course again we can visualize these by regions or other units to break down the spatial complexity a little bit and to better understand the broader patterns of what the key issues are. So we see over large areas the majority greatest threat is climate change producing low rainfall. In other cases it's to do with border proximity and so on. So that's MENARA. We can of course look at any of these results, download them as GIS files for use in geographical information systems, allowing us to do further analysis. So you see I've just clicked to download the relative prognosis index. It's now preparing that data for me, and once it's done I can get the file, and I will have in this case an ArcASCII file that I can use in a geographical information system. If we want to view this final aggregate index by region, again here we are. This time we'll be looking at the average because this is a scalar data set, and we can see that for Turkey we have a couple of areas where the prognosis is looking pretty good, other areas where we have much lower values, and again we can dig into this to work out why that is by taking this out to a Google map and looking for areas of interest, querying the inputs and seeing what the key attributes are. You can run MENARA for any basin in the world and any country in the world, but you can also run it for subsets of countries in order to look within those areas. And always the indices are relative to your study area. So if your study area is a country, then the indices are relative to all of the pixels in that country. Thanks for listening. Have a go with the tool. Hope you find it useful. Give us some feedback.